Now in this lecture we will be looking into other type of reactions of organic reactions, which are electrophilic substitution reactions, free radical substitution reactions, right? We know that by now what are electrophiles and what are free radicals, right? Electrophiles are electron loving, right? They are electron deficient species, right? And free radicals are reaction intermediates, right? They possess an odd electron, they possess a single electron, right? Due to which they are highly reactive, right? They react quickly, right? Their reactivity is high, so because they want to pair up their single electron, right? So electrophilic substitution reactions, these are mainly undergone by, these reactions are seen in your benzene compounds, right? In benzene we have many electrophilic substitution reactions like halogenation, sulfonation, nitration. All these are electrophilic substitution reactions. And same as in nucleophilic substitution reactions that we studied in the previous lecture, in electrophilic substitution reactions also, a stronger electrophile will replace a weaker electrophile, right? For example, if we take the example of nitration of phenol, this is your benzene ring, right? In nitration of phenol, the electrophile that gets generated is your NO2, right? And this reaction takes place in the presence of sulfuric acid, concentrated sulfuric acid and concentrated nitric acid, right? Concentrated nitric acid and your concentrated sulfuric acid. We will learn this when we will do the chapter hydrocarbons, when we will study benzene and hydrocarbon. We will do all this in detail. So when this is an electrophile, and we know that your benzene, right? Benzene has hydrogen atoms, right? And we know that hydrogen atoms act as hydrogen atom, right? Hydrogen atom will be removed as a proton, right? So this hydrogen ion, we know that hydrogen ion is a proton, right? This is an electrophile, right? And this electrophile is weaker compared to your NO2 plus. So this stronger electrophile will replace proton, which is a weaker electrophile, right? Resulting into the formation of nitrobenzene. This reaction is called as nitration, right? This leads to the formation of your nitrobenzene, right? And this is we call it as electrophilic substitution. Why? Because in this, a stronger electrophile will replace a weaker electrophile, right? So substitution is for a stronger electrophile, right? It is replacing a weaker electrophile. And this is it, and this is denoted by Se, right? And mainly we see these reactions, electrophilic reactions in case of arenes, right? Arenes are compounds that contain benzene nucleus, right? Commonly these reactions are seen in arenes, right? Benzene, right? And compounds of benzene, and these are less commonly seen in alkanes, right? So, and these are denoted by Se, right? Electrophilic substitution reactions are denoted by Se, whereas S stands for substitution and E stands for electrophile, right? Substitution electrophilic reactions. Now let's look into free radical reactions. Free radical reactions. Free radicals, for example, chlorine. If chlorine in the presence of UV rays or sunlight will break to give you chlorine radicals. These are chlorine free radicals. These are these are your reaction intermediates, right, and are highly reactive. Why they are highly reactive? Because they have a single electron, right, and they want to pair up this single electron. So in order to pair up the single electron that they possess, they show high reactivity, right? So example of free radical substitution. Now when we say free radical substitution, it means substitution will take place with the help of these highly reactive free radicals, right? Example is halogenation of alkanes. For example, this reaction takes place in the presence of sunlight, right, and it forms this product. If you look into the mechanism of this reaction, the reaction takes place through mainly 3 steps, right? The reaction takes place through 3 steps, free radical reactions. First is your initiation, right? In initiation reaction, you have the initiation stage, propagation stage, then you have a termination stage. In initiation stage, what happens is your free radicals, in initiation stage, free radicals will get generated. Free radicals will generate, right? For example, like I said here, the same chlorine will form 2 chlorine free radicals, right, in the presence of sunlight, UV rays. So here, this is initiation stage of free radical substitution reaction, whereas the reaction is initiated by free radicals. Now you have 2 free radicals, right? So one of the free radicals now will attack your methane molecule, right, and that would be your propagation step, right? A chlorine free radical will attack a methane molecule to form HCl and methyl free radical, right? So second would be your propagation step, right, where this free radical, chlorine free radical, which we know is highly reactive, and it's trying to pair it up itself, right? Here you have 2, actually this bond is nothing but a pair of electrons, right? So when your chlorine will attack it, right, what it will do is it will remove hydrogen, right? Now hydrogen would, this would be a homolytic bond fission, right? This would be kind of homolytic bond fission, where 1 electron will stay with methyl, right, and 1 electron will go with hydrogen, right, like this. What it will form is your methyl free radical, right, methyl free radical. And if you look at this Cl will react with hydrogen to form HCl, right? Here it will form HCl. Now this methyl free radical will then attack another chlorine molecule, right? This methyl free radical will attack another chlorine molecule, let's write it like this, right? It will attack another chlorine molecule to form this product, right? It will attack another chlorine molecule to form CH3Cl, right? And now you have still 1 chlorine free radical, right? So here 1 chlorine free radical is here, 1 chlorine free, these were actually 2 chlorine free radical. One was used to attack methane molecule in propagation step, where it formed methyl free radical and HCl, right? 1 free radical is used right? Now this methyl free radical will react with another or attack another chlorine molecule, right, to form methyl chloride and a chlorine free radical, right? Now we would be looking into the termination step, right? Now we are proceeding towards the third step, which is your termination step, right? So we also need to look into one more thing in this propagation step, right? The step A and B, right? These two steps, this step and this step, reoccur with methyl chloride and subsequent products to successfully form. Okay, we know that in this reaction, right, in this reaction, this methyl chloride will further undergo substitution, right, to form where more hydrogen atoms would be replaced to form CH2Cl2, CHCl3 and CCl4. These compounds will get formed, right? Now in the same propagation step, right, this will further react, right, with chlorine free radicals to give these products, right? Now in the final step, which is your termination step, now in termination step would be where these formation of these free radicals will end up somehow, right? Because we have two types of free radicals here in this chain reaction. If you see, we have two types of free radicals. One is chlorine free radicals, the other is methyl free radicals, right? In the termination step, the reaction would be such that the formation of these free radicals will stop, right? Because unless the formation of these free radicals will not stop, the reaction won't stop, right? Reaction won't terminate. So here in this termination step, free radicals will react to form neutral molecules, form ethane, right? And this is the reaction between free radicals, right? This is the termination step where free radicals will react. The chlorine free radicals may get deactivated, right, by these mechanisms, right, and the reaction will come to a halt. Reaction will stop, right? So by this reaction, this reaction, chlorine free radicals would be deactivated, right? In the first step, in the initiation step, chlorine free radicals were activated with the help of sunlight, right, UV rays. Now when the chlorine free radical was formed, it progressed the reaction by attacking the methane molecule first, right? Then it formed, this step formed methyl free radical, right? Then it further undergoes substitution reaction to form these products, right? Now in the termination step, we need to stop the formation of these free radicals should get stopped. So these free radicals will react among one another to form these neutral molecules, right? Where basically the free radicals are deactivated in these steps to form products, right? So here we have understood two important reactions: electrophilic substitution reactions, where a stronger electrophile will replace a weaker electrophile, then a free radical substitution reaction. In free radical substitution reaction, we have reaction intermediates free radicals which are highly reactive because they want to pair up their electrons, right? So in free radical substitution reactions, remember we have three stages: initiation stage, propagation stage and termination stage, right? In termination stage, the free radicals will get deactivated, due to which this reaction was continuing, right? I hope this is clear. Thanks.